Hello chemists, you've caught me in the middle of preparing my solid phase extraction manifold. Come along with me on this journey and I'll show you how we set this up and use it. The manifold itself consists of this container here with a lid, and there are 12 different ports on the top of the lid. And then we're going to use a single head diaphragm pump to pull a vacuum on this chamber to perform the solid phase extraction. We're going to connect our pump to the chamber using a length of vacuum tubing on the hose barb port on the pump and the front port on the manifold. And we're going to plug our pump into the outlet on the hood, and then there is a single power switch on the pump that we can flip on to start pulling a vacuum on the chamber. We'll turn that off for now. The next piece of the assembly is that we are going to need a container inside of the housing to collect our eluent from the solid phase extraction tube. So when you are performing the first few steps, you're going to use a large beaker to collect the eluent, and eventually you'll switch over to a collection tube. The next pieces of our apparatus are the solid phase extraction cartridge itself, and we're using the Sapel Clean NV18, which is a functionalized silica cartridges, and these are pre-packed for you. They're going to attach to this lure lock fitting, and then we're going to pass this lure lock fitting and the connected tubing through one of these ports. To open the port, you're going to unscrew it a bit. You may want to take it all the way out in order to insert the sample tube through. And you'll find that the lure lock fitting seats itself right in the top of the manifold port here. So then we're going to pass the tubing down through and then screw the port back into its place here. We don't want to screw this down all the way, as that would cause the sample line through the manifold port to become kinked or have it be cut off. But we do want it to be tight enough so that it forms an airtight seal there. There's a little bit of balance here. If you go till you just feel it starting to become finger tight and then back off maybe 1/8 of a turn, it should be about the right setting. All right, our manifold is assembled. The next step here is that we are going to precondition the column. You're going to be doing 2 preconditioning steps. The first is going to be using 10 milliliters of methanol, and then we're going to switch over to a solvent system that is more similar to what we are going to, or to our sample matrix, which is 5% methanol, 95% millicu water. And our sample matrix is going to be water for this experiment. So this is also the time that you're going to want to dial in the flow rate through your solid phase extraction cartridge. To do this, we're going to turn on our sample pump, and you can see here the gauge is starting to pull a vacuum. There was already a tiny bit of solvent in this cartridge from a previous demo there, so you're not going to see these bubbles passing through on yours until you start to add liquid to the tube. All right, there are 2 ways to add liquid to your sample tubes. One is to use a graduated cylinder and just pour this in as such. And the idea here is that we don't want to allow this column to run dry once we start working with our actual sample. So we're going to condition with our 10 milliliters of methanol, and I'm going to want to dial in my flow rate right now. Right now it looks like it's going a little bit fast. There are 2 ways I can control the strength of the vacuum here. I can open this port, this white plastic knurled fitting here on the front of the manifold, and that allows air to bypass the vacuum and slow down the rate of flow through the tube. We want to dial this into about 1 to 2 drops per second. If it's a little bit faster than that, ask your lab instructor if what you've got going on is going to be okay for you. And then the second way is to use this check valve here at the pump itself. And if I open that up, it's going to decrease the vacuum that we're pulling as well. All right, you can see my liquid is starting to get down towards the bottom, so I'm going to add my next little bit of methanol here to avoid letting the column run dry. Once I've passed this 10 milliliters of methanol through, I would do the same thing with 10 milliliters of 5% methanol, 95% millicube water. The other mechanism for getting sample into the tube that I'll show you in the next part here when I load our sample is to use one of these vacuum lines that will attach to the top of the manifold, to the solid phase extraction tube, and then you put the other end in the sample that you want to pull up. This is a little tricky and you might have to use get gravity on your side to make that work. I'll show you how that works. Alright, now that you've preconditioned your solid phase extractor cartridge, you can see we've got our drops flowing out the bottom of the tube into our collection vessel, and we're just about to run out of solution at the top of the cartridge there. So now is the time that we're going to start loading our sample. And you can do this in several ways. You can decant directly from your container, which is either going to be a 100 milliliter ball flask for your quality control materials, or the baby bottles for your unknown sample or your laboratory fortified matrix. We're going to fast forward a bit here, but the ultimate goal is to load the entirety of your 100 milliliter sample onto the cartridge and to let all of that solution pass through the cartridge before moving on to the elution step. Alright, we've come to the end of our loading phase here, and the last of our sample is now running through the cartridge. At this point, we do want to let all of that solution pass through the cartridge and give the cartridge a little bit of time to dry. The reason we're going to do this at this point is that as our sample passes through the solid phase extraction cartridge, all of our analyte should be retained on the solid phase as the water and the rest of the matrix pass through. This has a couple of advantages. It's concentrating our sample down because we can elute in a much smaller volume than we pass through the cartridge, and it's removing the matrix from our analyte, so we should be able to get a much cleaner sample in what we elute off of the cartridge than what we started with. Part of that is that we don't want any water to be contained in our sample at the end here. So once you have passed all of your sample through the cartridge, give it a little bit more time to continue flowing through until you see that there are no more drops of water coming out, and then you can assume that your cartridge is fairly dry. Once you've reached that point, then it's time to move on to the elution phase of the procedure. So I'm going to stop the pump right now by turning off the power switch. I'm going to open the check valve, or the bypass valve on the manifold to allow the vacuum to dissipate. And then I am going to remove the top of the chamber. I'm going to remove my waste beaker, and I'm going to replace it with a elution tube holder here, and the key with this is to make sure that the tube height is appropriate to not allow any of your sample to escape and fall into the rest of the chamber without being collected. Alright, so I'm only having one tube in here, you're going to have multiple going at the same time. And we can replace our chamber lid, and at this point we can begin to elute our analyte from the column. And To elute the BPA into the collection tube there, again, we're going to use 5 milliliters of methanol. So I'm going to add my methanol. I'm going to close the bypass valve and start the pump again. Now our methanol should begin flowing through the extraction cartridge, and our BPA is going to partition into the methanol from the solid phase and be eluted into our collection vessel. You can just now start to see that coming through, as it did take a little bit of time for that methanol to completely pass through the bed of the cartridge. Now my flow is a little fast here, so I should definitely slow this down by opening up that bypass valve. We need to allow enough time for the methanol to interact with the solid phase to ensure that the BPA has time to partition into the methanol and not be retained on the solid phase inside of the cartridge. Alright, so that's our extraction procedure. One thing that I didn't mention in the beginning when we were loading the sample is that we should make sure that the sample is acidified before loading it on the cartridge, which will allow for maximum retention of the BPA on that solid phase. And once we're done here and we've collected all of our eluent, again, we're going to let all of that pass through until the cartridge is dry and collect everything inside of our collection vessel. The next step will be to move on to concentrate this down even further. We've already concentrated our sample down from 100 milliliters to 5 milliliters, and we're going to further concentrate this using a nitrogen evaporation system.